Hello everyone, welcome to my channel Spire Bytes, where we make networking simple for beginners. Have you ever wondered why does a switch make your network faster, but a router makes it more secure? The answer lies in two concepts that confuse almost everyone at first, which are collision domain and broadcast domain. But don't worry, in next few minutes, we will understand both of them visually using some network diagrams. Now, let's understand these concepts using two different situations. First, imagine you are in a room full of people and suddenly everyone starts talking at the same time. What happens? Voices overlaps, people interrupt each other, and no one can clearly hear anything. And at the end, you might end up very confused, just like this rabbit.
Huh?
This is exactly what happens in a collision domain. Multiple devices try to send data at the same time and the signals interfere with each other. Now, imagine a different setup where one person stands up and speaks loudly, and everyone in the room hears the message whether they are interested or not. No confusion, no overlap, but also no control over who receives it. That's a broadcast domain. One device sends the data and all devices in the network receive it. Now, let's see how this happens in a real network. All these end devices are connected to this central device called hub. At this point, you might be wondering what exactly is a hub? Well, a hub is a very basic networking device. Think of it like a simple connector that links multiple computers together in a network. But here's the catch. It doesn't think or doesn't filter, and it also doesn't decide anything. Whatever data it receives, it simply sends to every connected device. Now, imagine two devices try to send data at the same time. For example, PC A and PC B are trying to send data to each other at the same time, and their signals are gonna collide. Because of this, only one device can successfully send data at a time, while others have to wait. This type of communication is called half duplex communication. So, this entire network becomes one collision domain. Now, here's something interesting. As the hub doesn't think, it just blindly forwards everything to all connected devices. This behavior becomes important when we talk about the broadcast next. As we discussed, one device can send data at a time in a hub-based network, which leads to a slower network as other devices need to wait until the first device completes its communication. So, how do we fix this problem? Well, the answer is switch. So, when we replace the hub with a switch, something important changes. A switch doesn't send data to every device like a hub. Instead, it sends data only to the intended device. Now, think about this. Each port on a switch acts like its own separate lane. So, if one device is sending data on one port, it doesn't interfere with another device sending data on the other port. Because of this, collisions are separated. Each port becomes its own collision domain. This means multiple devices can send data at the same time without crashing into each other. This is called full duplex communication. This smart behavior works when data is meant for a specific device. But what if one device sends data meant for all devices? That leads us to the concept of broadcast domain. Let's talk about broadcast on a switch and why they behave differently from normal traffic. First, Remember how each port on a switch acts like a separate lane. This works perfectly for normal traffic, which is when one device wants to send the data to one specific device. Here's where the switch is smart. It keeps a table of MAC addresses. A MAC address is a unique name for each device. When device sends the data to another device, a switch looks at the destination MAC addresses and sends the data only to the port where the device is connected. For example, let's say PC A wants to send data to PC B. So PC A will forward the message to the switch, and the switch will look into its MAC address table if the destination address is known to it. So PCP's MAC address is available in the MAC address table, and the outgoing port is G01. So the switch is going to forward that message out of the G01 port to the PCB. But sometimes a device doesn't know the MAC address of device it wants to talk to. For example, it might need to discover all devices on the network. In that case, the device sends a broadcast message which is meant for everyone. Since the broadcast does not have a specific MAC addresses, the switch has no choice but to forward it to all ports. So, even though switch reduces collision for the normal traffic, it cannot stop broadcast traffic. Only a router can block broadcast from going into the another network. This is why broadcast domains exist even in a switch-based network. We will discuss the process of packet forwarding in detail in the upcoming videos, so stay tuned. Moving forward, as we understand the concepts of collision domain and broadcast domains, let's do one small exercise here. Take a moment to determine how many collision and broadcast domains exist in this network. Pause, think it through, and let me know your answers into comment section, and we will discuss the answer shortly. Alright, so in this diagram there are total 4 collision domains and 1 broadcast domain. If you got that answer right, congratulations, you have understood the concept. For others, let's solve this step by step. First, collision domains. Let's quickly remember the rules. First, each switch port is one collision domain and a hub is one shared collision domain. Now, let's count. So there is a one collision domain from PC A to switch, a switch to PC C, and a switch to router, and the last, which is an important part, the hub side, is the fourth collision domain. So let's understand this a little bit more in depth. The switch connects to hub and the hub is connected to two computers. But a hub doesn't separate traffic. It just repeats everything to all ports. So all devices on the hub are sharing the same space. That means if two devices send data at the same time, it's gonna collide. So the entire hub segment counts as just one collision domain. There is total 4 collision domains in this network. Moving forward, now the broadcast domains. Only routers break broadcast domains. Here we have only one router. So every device can receive broadcast, which are denoted as green arrows in this diagram. So there is a one broadcast domain. Alright, that's it for this exercise. If you found this helpful, make sure to like the video and subscribe for more simple networking explanations. And if you have any questions or got stuck anywhere, please drop into the comments. I will make sure to reach out and help you out. Thanks for watching, and I'll see you in the next one.